Complex numbers in Argand plane. In this module, you will learn to represent the complex numbers in Argand plane. Mathematician Argand represented a complex number as a point in a two-dimensional Cartesian coordinate system known as Argand plane or a complex plane. A point whose coordinates are x, y represents a complex number x plus iota y in the Argand plane. The x-axis represents the real part of the complex number, so it is called the real axis. On the contrary, y-axis represents the imaginary part of the complex number, so it is called the imaginary axis. The distance of this point from the origin is known as the modulus, or the absolute value of the complex number x plus iota y. Also, the angle made by the line joining this point to the origin with the positive x-axis is called argument or amplitude of the given complex number. Now, before discussing polar representation of complex numbers, first let us understand the polar coordinate system. It is a two-dimensional coordinate system in which each point on a plane is determined by the radial distance r and an angle theta. The radial distance denotes the point's distance from a fixed point called pole, which is known as origin in the Cartesian plane. The angular coordinate denotes the angle swept in the anti-clockwise direction from the initial line known as the positive x-axis in the Cartesian plane. Now, consider a point representing a complex number x plus iota y in the Argand plane. If the length of the directed line segment joining the origin to this point is r, and theta is the angle made by this line segment with the positive x-axis, then polar coordinates of this point are r theta referred to origin as the pole and positive x-axis as the initial line. Now, to obtain x and y in terms of the polar coordinates r theta, draw a perpendicular on x-axis from this point to obtain the right triangle. In this right angle triangle, cos theta is equal to x upon r and sin theta is equal to y upon r. This further implies that x is equal to r cos theta and y is equal to r sin theta. Substituting these values of x and y in complex number x plus iota y, you get the polar representation of the given complex number as r into cos theta plus iota sin theta whole. Look at this right angle triangle again. Applying Pythagoras theorem, you get r is equal to square root of x square plus y square. The value of r represents the modulus or absolute value of the complex number x plus iota y. Also, angle theta is the argument or amplitude of the complex number x plus iota y. There corresponds a unique value of theta greater than equal to 0 and less than 2 pi to represent any non-zero complex number. If any two values of the complex argument differ by an exact integer multiple of 2 pi, they are considered equivalent because any number of multiple revolutions of 2 pi made around the central pole do not affect the actual location of the point plotted. The value of theta when limited to an interval minus pi to pi such that minus pi is excluded and pi is included in the interval, then the value of theta lying in this interval is called the principal argument. Notice that the size of this interval is also 2 pi. In this module you have learnt that A point whose coordinates are x, y represents a complex number x plus iota y in the Argand plane. The x-axis, called the real axis, represents the real part of the complex number, and the y-axis, called the imaginary axis, represents the imaginary part of the complex number. The distance of the point xy from the origin is known as modulus or absolute value of the complex number x plus iota y. The angle made by the line joining the point xy to the origin with the positive x-axis is called argument or amplitude of the given complex number. The polar form of the complex number z equal to x plus iota y is r into cos theta plus iota sin theta whole.